The interface of this login page is designed to be clear and user-friendly. At the top, there is an image showing the app's logo. Below the image, there is a label that shows a motivational quote, "The greatest health is health." Next, there are two text input boxes. One is labeled username and the other is password. The user can type the login details here. The password box hides the text with dots to keep it private. Under the text box, there are two buttons, one for sign up and one for login. The sign up button is used for creating a new account, while the login button is used to log in if the user already has an account. At the bottom, there is hidden message label that will show message like username incorrect or account successfully created based on what the user does. There are also non-visible components like sound effect, which is menu sound, correct sound, and error sound to give feedback, and CloudDB to store and check usernames and password online. In this box section of the login screen, the app uses CloudDB to handle the sign up and login functions. When the sign up button is clicked, the app stores the username and password entered by the user into CloudDB. The username is used as the tag and the password is the value to store. After saving the data, the app plays a sound called menu sound to indicate that the sign-up process is in progress. Next, when the data in CloudDB changes, the CloudDB one.data change block is triggered. This block checks if the tag that was changed matches the username entered. If it matches, it displays a success message saying account successfully created and plays a correct sound to notify the user that their account has been created successfully. When the login button is clicked, the app calls CloudDB1.getValue to retrieve the store password based on the entered username. If the username is not found in CloudDB, it means the account does not exist. So the app plays an error sound and shows the message username incorrect to inform the user. After that, the CloudDB1.getValue block is triggered once the data is received from CloudDB. It checks whether the retrieved tag and value match the entered username and password. If both the username and password are correct, the app plays a correct sound, stops any error sound, and navigates the user to a welcome page. However, if the password is incorrect, the app plays an error sound and displays the message, "The password is incorrect."
Welcome to My Health app. This is the welcome page of our Fit Health app. The page is designed to greet users after they log in. We use a custom background image showing a digital human figure to create a modern and engaging first impression. The message, "Welcome to My Health app," is placed in the center using a label inside a vertical arrangement to make it look neat and aligned. There's also a next button at the bottom that allows users to proceed to the main menu. At the bottom, we have non-visible components like text-to-speech and to sounds, which is welcome sound and menu sound, which are used for audio feedback. Now, let us look to the blocks used in this screen. When the welcome page initialized, the app first plays the welcome sound when it calls the text-to-speech.speak block to say welcome to my health app out loud. This makes the app more interactive and user-friendly. When the user clicks the next button, the welcome sound is stopped and menu sound is played to indicate a screen transition. Then, the app navigates to screen 1, which is the main menu of the app.
Welcome to my health app.
This is the menu interface of My Health app, which appear after the welcome page. At the top of the screen, there is a label titled My Health menu to show that this is the main navigation screen. Below that, there are 6 buttons, each inside its own layout block called vertical arrangement, and each one represents a different feature of the app. The first row contains buttons for water consumption and body mass index. This let the user track how much water they drink and calculate their BMI. The second row has a fitness coach button in the center, and the last row includes buttons for heartbeat rate and waist-hip ratio. Each button includes an image and a label to make it easy for the user to understand its function. The layout is neatly organized using horizontal arrangement and vertical arrangement components to keep everything aligned. The background is colorful and attractive, making the interface more engaging. At the bottom, there are 2 non-visible components, which is menu sound and start sound, which are used to play sounds when users interact with the buttons, making the app more interactive. The blocks in the menu page control what happens when each button is clicked. When users tap any button, a menu sound plays, and then the app opens a new screen based on which button the user press. For example, clicking the water button takes user to the water consumption screen. The BMI button opens the BMI calculator. The fitness button opens the fitness tracker. The heartbeat button leads to the heart rate monitor. The WHR button opens the waist to hip ratio calculator, and the logout buttons take the user back to the login page.
Now, let's continue with water consumption page of the app. Here, user can find out if they are drinking enough water based on their weight. Let's take a quick tour of the user interface and explain the component used. At the top, we have the title, Do You Drink Enough Water?, which gives users an idea of what the page is all about. Next, you'll notice an image showing a person's body with a weight chart. This visual shows the recommended daily water intake based on the user's weight. For example, if the user weighs 72 kg, the app will suggest the number of glasses of water they should drink each day. Below the chart is the text box where users can input the number of glasses of water they currently drink per day. This allows the app to track and compare their actual intake against the recommended amount. At the bottom, there's a calculate button, which the user clicks to get their personalized water intake suggestion. Once the button is clicked, the app calculates and displays the result. And don't forget the home button at the bottom of the screen. This allows users to easily return to the main screen whenever needed. Now, let's take a closer look at the component used in MIT App Inventor to create this interface. Here, we have the vertical arrangement component that arrange the element vertically on the screen, ensuring they are easy to follow for the user. The text box is where users input the number of glasses of water they drink daily. This is a crucial element because it directly fits into our calculation process. The label displays a chart with the recommended daily intake. It's an image component that serves as a visual guide for users. Here, we have the calculate button, which is an interactive element. When clicked, it triggers the calculation and displays the result. We also have a sound component, specifically sound 1, that plays a feedback sound when the button is pressed. This is to enhance the user experience and make the app feel more interactive. And lastly, the home button allows easy navigation back to the main screen, ensuring the user can always find their way around the app. Now, let us dive into the blocks that make this page work. When the calculate button is clicked, the corresponding block triggers a series of actions. This block is responsible for capturing the input from the text block, which is the number of glasses the user drinks daily. There's also a sound block connected to sound 1. When the button is pressed, it plays a sound, giving the user feedback that the action was successful. The next button calculates the user's recommended daily water intake. Based on the user's input, the app uses a predefined formula. For example, the app can calculate water intake as weight in kg times 0.033, and it uses this to suggest the number of glasses the user should drink. Once the calculation is complete, the result is displayed on the label called liquid underscore output. This is done by assigning the calculated value to the text property of the label, allowing the user to see their personalized water intake recommendation. If needed, the app can also navigate to menu screen by clicking home button. Welcome to the BIMI calculator page of My Health app. This page includes several key interface elements. At the top, there is a BMI scale image showing a different BMI categories, from underweight to morbidly obese. This helps users visually understand their results. Below the image, there are labels and text boxes for user input. The first label is high in centimeter, and next to it is a text box where the user enters their height. The second label is weight in kg, with another text box for the user to type in their weight. The third label is your BMI equals to, followed by a blank label that will display the BMI result of the calculation. At the bottom right, there's a green calculate button with a calculator icon. When users click this button, their BMI is calculated. There's also a home button at the bottom center to return to the menu page. Now, let us look at how the code blocks make this BMI page work. When the calculate button is clicked, the app gets the weight from weight input.txt, then it takes the height from height input.txt and squares it. It divides the weight by the square of height in meters using this formula. BMI equals to weight divided by height square divided by 10,000. The result is then shown in the label BMI underscore output, rounded to one decimal place. I also added a result underscore sound block to play a sound after the calculation to give the feedback to the user. When the home button is clicked, the app plays a menu sound using menu underscore sound.play. Then it uses the block open another screen to go back to the main menu or screen 1. So that's how the BMI calculator page works in my app. It allows users to easily enter their height and weight, calculate BMI, and get categorized based on their BMI scale above.
This is the heart rate calculator screen in my Fit Health application. At the top, I use a label component to display the screen title, which is heart rate calculator. Below that, there's another label that gives instruction. It tells the user to count the heartbeats for 15 seconds. I use a button named start 15 seconds to start the 15 second countdown, and a label called second 15 to show the timer as it counts down. Once the countdown ends, the user enters their counted beats in a text box called enter beats. Then there's a button labeled calculate heart rate, which when click calculate the BPM by multiplying the number of beats by 4. The result is shown in two labels, which is your heart rate displays and calculate BPM, and the health status gives a message like normal or high depending on the results. I also include a home icon button at the bottom to let users return to their main menu. Finally, I've added a sound component to play feedback audio when the button is clicked, and clock component is used to manage the 15-second countdown timer. Okay, now let's continue to the blocks. So how we use the app is by clicking the start 15 seconds and wait for 15 seconds. Okay, when the notifier is up, and then we enter our heartbeat at the text box, and then we click the calculate heartbeat, and then you can see it shows your heart rate is how many BPM and your health status. These are the logic blocks that control the heart rate calculator feature in the Fit Health application. First, I create a global variable called time left, which starts at 50 seconds when the user taps the start 50-second button. Then timer begins, the label showing the countdown updates every second using clock 1 timer. As the time counts down, the clock 1 block reduces time left by 1 until it reaches 0. At the point the clock is disabled, the countdown is reset and the app plays a times up sound and shows a pop-up message using the notifier component. Then when the user enters their heartbeat count and press calculator heart rate, the app multiples the beats by 4 to get the BPM beats per minute. The result is displayed using a label. After that, the apps check the BPM value. If it's below 60, it shows health status low. If it's between 60 and 100, the status is normal, and it's above 100, it shows high. Lastly, when the user taps the home button, it displays a sound and sends the user back to the main screen.
Next, Health app for calculating the waist-heat ratio. So what is waist-heat ratio? It's a simple health measurement that compares the waist and hip size to check body fat distribution. A higher waist-heat ratio may indicate a higher risk of heart disease, while a lower waist-heat ratio is generally healthier. As we can see, this is the MIT App Inventor interface where the app was built. We use drag and drop components such as label for title, result and output message, a switch to select gender, text box for entering weight and heat value, button to calculate the result and home button, image for visual guides, and horizontal arrangement to organize everything neatly. I will show how the waist-heat ratio function works. First, select the gender. Next, enter the waist and hip measurements in centimeters. Then, tap the calculate button. So the waist-hip ratio and the result interpretation will be displayed. Next, this is the MIT App Inventor block setup for our waist-hip ratio app. First, we initialize the global variable WHR to 0. When the calculate button is clicked, it takes the waist and hip input, calculate the ratio and round it to 2 decimal places. It then displays the WHR value on the screen. Next, based on the gender switch, the app checks if the user is male or female and compare the WHR against the half risk threshold. If it's above the risk level, it shows high risk, otherwise, it shows low risk. We also add sound effect and home button for better user experience. So this block controls the entire logic behind the app's functionality.
The fitness coach screen is the main interface where user can monitor their physical activity. It uses the pedometer sensor to track step, distance walk and time spent walking. The screen also includes buttons to start, stop, reset and navigate between screens. Users receive real-time update on their performance as well as optional sound feedback and calorie burn display. The fitness coach screen is the heart of our app, where users can monitor the activity in real time. The start, stop and reset button control the pedometer. As the user walks, the app updates the number of steps, distance walked and time passed. The home button brings user back to the main screen with sound feedback. Another button also shows the walking duration in text format. We also include a calorie burn display that uses step count and user input to calculate estimate energy use. The interface is clean, easy to use and help users stay active and motivated.